The idea of traveling between the stars has always fascinated us, but the hard truth is, it probably will never happen. Sound pessimistic? Then consider this. The closest star to us, Proxima Centauri, is at an absurd distance, about 266,000 times farther than the Sun. And if we compare it to a trip to the Moon, that distance is over 100 million times greater. It's like trying to cross an ocean using a pool float. Even light, which travels at the fastest known speed in the universe, takes 4.3 years to reach us from Proxima Centauri. In comparison, sunlight takes only 8.5 minutes. These numbers highlight the biggest obstacle to interstellar travel, the colossal distance between stars. If we consider that our galaxy spans around 100,000 light-years in diameter, and the observable universe stretches over 12 billion light-years, the feeling of technological helplessness is inevitable. Today, our fastest spacecraft, Voyager 1, travels at 17 kilometers per second. Even so, it would take 75,000 years to reach Proxima Centauri. That's because chemical-fueled rockets, even with gravitational boosts from Jupiter and Saturn, are completely ineffective for such vast distances. It would take a gigantic technological leap. Many ideas have already been proposed. Ships powered by nuclear fusion or fission, propulsion through matter-antimatter annihilation, or giant sails pushed by light. But all of these remain purely theoretical, requiring decades of research and almost unimaginable resources to become reality. Even bolder proposals involve so-called warp drives or wormholes. Incredible concepts, yes, but they exist only in the math of general relativity and science fiction. And the problem isn't just about building bigger and faster spacecraft. There's a physical barrier that makes all of this practically impossible: the very structure of reality. As Einstein demonstrated in his theory of special relativity, no object with mass can exceed the speed of light. This is one of the most solid laws in modern physics, confirmed by countless experiments. It's not a belief or a theory, it's a verified fact. Einstein showed that energy and mass are directly linked through the famous equation E equals mc squared. As we accelerate an object, the energy we apply begins to increase its mass, even if imperceptibly. The faster it moves, the more energy is needed to keep accelerating. That's because part of that energy is being converted into mass, and the more mass it has, the harder it becomes to move it. If an 80-kilogram person were to travel at 99.9% the speed of light, their effective mass would be nearly 2 tons. That means pushing that person even faster would require absurd and practically infinite amounts of energy. So no matter how close we get to the speed of light, we'll never reach it, much less surpass it. Even if it were somehow possible, like magic, to reach that speed, the trip to Proxima Centauri would still take 4.3 years. That's the best we could do, even in the most optimistic scenario. In other words, fast travel between stars like we see in sci-fi movies simply doesn't hold up against the laws of physics. And if the laws of physics already make interstellar travel practically unfeasible, there's still another equally complex issue: time. For someone on board the spacecraft, time wouldn't pass the same way as it does for those who stayed on Earth. This happens due to an effect known as time dilation, predicted by Einstein's relativity. At this point, you might be thinking, but couldn't that be an advantage? After all, for someone traveling near the speed of light, time goes by more slowly. In theory, we could explore distant stars and return to Earth decades later, while only a few years had passed for the crew. But in practice, this creates a whole set of dilemmas. Imagine leaving your planet, your family, your civilization, and coming back to a world that's completely changed, or who knows, even extinct. This effect, rather than being a solution, actually makes such missions even more emotionally and logistically complicated. On top of that, we can't ignore the dangers of interstellar space itself. Although it may seem empty, space is far from being completely lifeless. With every kilometer traveled, a spacecraft would face dust particles, hydrogen atoms, cosmic radiation, and even small fragments of rock. At speeds close to light, a single grain of sand could hit like a bomb, causing catastrophic damage to the structure of the ship. And unlike today's missions, where maintenance and corrections are possible, an interstellar mission would have to be self-sufficient for decades or even centuries. Even if we developed protective shields, near-infinite energy systems, and ultra-resistant materials, we would only be solving the technical problems, but the social and psychological challenges would be an equally massive obstacle. A mission that lasted generations would require the descendants of the original astronauts to accept living and dying in space, never seeing a planet again. That's not even counting the internal conflicts, extreme isolation, and long-term effects of microgravity on the human body. And if someone thought about using cryogenics, freezing the body to be awakened only upon arrival, we'd run into scientific limitations there too. We still haven't figured out how to freeze and thaw human tissue without causing irreversible damage. Even with significant progress, this technology is nowhere near viable for such long and risky missions. All of this technical and human complexity leads us to reflect on a fundamental point. Do other civilizations in the universe face these same barriers? This question lies at the heart of the famous Fermi paradox. If the universe is so vast and ancient, and if intelligent life is common, why haven't we found anyone yet? One possible answer is precisely this. Maybe interstellar travel isn't just difficult. Maybe it's simply impossible. Maybe every civilization that reaches a certain technological level hits the same walls we're beginning to discover now. Physics imposes limits that can't be bypassed, and the cost of defying those limits might be more than any society is willing to pay. The conclusion that many scientists and thinkers are beginning to accept is that, as tempting as it may be to look at the stars as future destinations, perhaps our real challenge is taking care of the planet we already inhabit. Because in the end, escaping Earth might not be a real alternative, at least not on an interstellar scale. Thinking about all these limitations might seem discouraging, but it also invites us to reflect on how special we truly are. Instead of imagining the universe waiting for us out there, maybe we should consider the possibility that we're already in the right place. Earth isn't just our starting point. It might be, for a long time, the only possible home for humanity. Of course, we can still explore the solar system, manned missions to Mars, bases on the moon, probes to the moons of Jupiter and Saturn. All of that is within our reach in the coming decades. But leaving our cosmic backyard is another story. It would be like trying to swim to another island in a sea full of storms, sharks, and dangerous currents, without knowing for sure if there's land on the other side. Science has taken us far. In just a century, we've gone from the first powered flight to probes traveling to the edges of the solar system. That shows how immense our potential for innovation is. But it also reveals that, despite our ingenuity, there are natural limits we may never be able to surpass. When we look up at the night sky and see billions of stars, it's tempting to imagine that each one could host worlds with intelligent life waiting to be found. But perhaps those civilizations, if they exist, are just as stuck as we are, isolated by vast distances, unbreakable physical laws, and a time that flows relentlessly. And even if interstellar travel were possible, an even more complex question would arise. For what purpose? To colonize other planets? To escape a catastrophe on Earth? Or simply to satisfy our ancestral curiosity to go beyond? Each of these motivations brings deep ethical, social, and philosophical dilemmas. Colonizing another planet, for example, would require transforming hostile environments into habitable places. That means manipulating nature on an extreme level, something we can barely do sustainably on our own planet. Would we be capable of creating a new Earth without repeating the same mistakes we made here? Moreover, throughout history, every time a society tried to conquer new territories, conflicts followed. It's naive to think that an interstellar mission wouldn't bring political, economic, or cultural disputes, especially if it involved decades of isolation and crucial decisions for the crew's survival. Given all this, perhaps the greatest value of space exploration is precisely this: to make us look inward, to understand that we are fragile, limited, and at the same time incredibly privileged to live on a planet with the perfect conditions for life, an oasis in the middle of a cosmic desert. The challenge ahead is not just technological, but existential. We need to accept that, at least for now, the universe is not an open field waiting to be conquered. It's a hostile, immense place full of boundaries that don't bend to our will. But that doesn't mean we should give up. It means we should channel our creativity, our knowledge, and our resources into protecting what we already have, to invest in science and keep exploring, but with our feet on the ground, or rather, with our feet on Earth. Who knows? One day, with breakthroughs we can't even imagine yet, all of this could change. Maybe a new kind of physics will emerge, new forms of energy, or even a shortcut through space-time folds. But until then, the best interstellar journey we can take is this one, diving into knowledge, curiosity, and the understanding that, even without leaving the planet, we are already sailing through the cosmos every day, aboard a spaceship called Earth. Share your thoughts on all of this in the comments. If you liked this video, leave a like, subscribe, and share it with anyone who's also passionate about the universe. Consider becoming a member to support the channel. Thanks for watching, and see you on the next journey through the cosmos.